Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's read some code together, shall we? What we have on the menu today is to finish the dramatic reading of other JSFX that do some form of scrolling display, in particular waveform displays that scroll, because we spent a lot of time on this stream talking about this issue. So I thought it would be entertaining and useful to see how other people do this. And last time we were here, when we started this dramatic reading, we looked at the source for this inline input viewer. Then we looked at the source of this wave scope effect. And mostly what we learned from these two was that we know how they work. We did something similar when we were working on our own waveform display. And we are not in love with the way that they work. They have some issues, including a glitch that you can actually see on the screen right now. It's a very subtle thing here, but you can see this trace. It's not really part of the waveform, it's a glitch. So today I thought we would look at something by Cockos. And perhaps we'll get to some other examples here as well. We have a compressor by Psyche that does a scrolling waveform thing. And we have an effect by Geraint Love that does a scrolling waveform thing. And it would be nice to see how these other developers do, because they are developers that I look up to. They know a lot more about JSFX than I do. But I thought we would start with the Cockos plugin itself. It comes with REAPER, and it's supposed to be a demonstration of how to do things. So there is one wrinkle, and that is an oscilloscope is supposed to let you, and this one does let you, zoom into the waveform arbitrarily to the sample level. And that means that the oscilloscope is required to hold as much as you are able to zoom out. So that's 5 seconds in this case. And perhaps you can even go further into the past. So it seems like you can go further five more seconds into the past, which means that this is storing 10 seconds worth of audio. And that means it is probably, we are going to see the code for this, but probably it is literally just storing every sample for 10 seconds. And that is more than we need. We don't need to store every sample, and that's more than we want. Because we don't want to plot every sample, we just want to plot this shape. And this shape is made of thousands of samples, but we don't want to paint the same pixel over and over thousands of times. And also, if we want to have, and we do want to have, a feature that this doesn't have, and that is to have some sort of contour, then we need to know what the blob is to draw a little line for the contour of the blob. So there is that. We need to be, when we are looking at the source for this guy, we need to be aware that the trade-offs that we are making are slightly different. But yeah, let's take a look. Let's see what this effect looks like. I will copy the code. Oops. I will copy the code from here. Or perhaps I would just look at the file and copy the file. Doesn't really matter. I'll just copy the code from here, paste into another buffer, and perhaps I will save this as leafac Oscilloscope.jsfx. And I'll put my name here so it shows up differently. And that's just in case we want to play around with the code by deleting some parts of the code. We can, and we won't be messing with my REAPER installation. Where is it? It's here. So now we have this version that is supposed to be working just the same, but it will let us change anything. And I will preserve this other one that comes with REAPER. So let's see what we have here. And my preferred way of reading code is by interaction. So I prefer to read the code by moving things around, perhaps renaming variables, that sort of thing. And the first thing that I notice about this code is that it doesn't use any imports. And that's important because that means that the whole source of the effect is right here. But also it's important because if it was using some import, we would have to copy and paste the imports as well for the effect to continue to work. And as you can see, that was not the case because we are still seeing everything working just fine. Okay, I will remove stuff that I know I don't want to look at because I already know that this effect is probably going to be bigger. It's around 500 lines, and that's bigger than the other ones we looked at. So as I said, I like to read code by interacting with the code. So one of the interactions is to just remove what I don't care about. And then there is this view size, and yeah, it goes in steps of 1, and it is going up to 5,000 milliseconds, which is 5 seconds, as we saw here when we zoomed out. And this is using a minus to say, don't show this slider, but perhaps if we remove the minus, we will see the sliders. Here are the sliders, and I can move them around, and they have pretty much the same effect as these boxes. And I kind of can see why they decided to not use a slider and use a box instead. I can see two reasons actually. The first is that you can, if you want, put this effect on the mixer control panel. And then the boxes are still interactive. And the boxes are in front of the waveform, so that may not be perfect, but the boxes are still interactive, so that's a nice effect of having the boxes. But also, and I guess perhaps this is even more important, this is showing the length in seconds, but as we scroll to the left and it becomes a very small number, it changes from seconds to hertz. So it's a nice quality of life thing, where when you have 1 millisecond, it shows up as 1 kilohertz. And perhaps if you're this much zoomed into the waveform, it is because you care about one cycle of the waveform. Perhaps you have a sine wave going on and you want to see one cycle, and you want to be able to tell what the frequency of that cycle is just based on this timeline as well as on this parameter. Okay, then there is the vertical zoom, and that's another slider. And for this one, I don't know why it's not a slider. It probably could have been a slider, except maybe for the interactivity here. And also the range seems to be represented in decibels here. So the scrolling over here is a lot gentler than the scrolling here. So here are two reasons why sliders don't cut it. And there are hacks around this, but in general, JSFX have sliders that are, first of all, in a single unit of measurement. You cannot go from milliseconds to hertz. And I guess perhaps even more importantly, these sliders are always linear. And sometimes you want to have a slider that has a bigger range when you're physically scrolling the mouse. You want to have a bigger range for some values and then a smaller range for other values that are perhaps less useful. And that's not something you can do with sliders. And there are hacks around this, as I mentioned. One hack around this is you can have a slider go from 0 to 1 and then compute the actual parameter based on a normalized value. And then you can devote maybe from 0 to 0.75, you could devote to the part that you care more about. In this case, I guess it would be the values with lower dBs, like up to 20 dB, let's say. And then the rest from 0.75 to 1, we could devote that to the part that we care less about. For instance, going down to minus 450 dB. Yeah, and I need to move my cursor a lot more to make these changes happen when I'm using this box. So probably they do some scaling here of the mouse movement. And then there's this retriggering thing that, to be honest, I think I would have made it a drop-down really. They have it here, so you can click, but a drop-down can get you to where you want, like ascending immediately. So if you are on instant, you can go to ascending. Come on, let's do this. If you are in instant and you want to go to ascending, you can go there in one click. And here you have to cycle through all the options. But perhaps because everything else was a box, this was made into a box as well. Okay, so this is... I can see why they have these options here. We never really talked about these options, though they are kind of the first thing you see in the JSFX documentation. And this is to set names for the pins, the ins and outs. And because it's being explicit, the names here show up. And because it doesn't have any explicit out pins, it doesn't even try to pin things to the output. We tend to not do this. We tend to just go with the default. If you don't have these pins, then the effect is just going to listen for any number of channels. Like this, and it will be default names, JS input, JS output. And it will listen for any number of channels, and it will not affect the audio in any way. As long as we don't write to the samples, it's not going to affect the audio. So perhaps it is a nice thing, perhaps it is a good practice to always declare ins and outs. But for most effects, I like the idea of having them as multi-channel. So if you don't declare pins, by default, they will just be the number of channels on the track. And I kind of like this behavior. If we had something like a compressor, perhaps we would like to have explicit pins so we could say sidechain, for instance. Or perhaps if our effect is stereo by design, perhaps it would be nice to limit the number of pins because it doesn't really make sense to read samples 3 and 4 if we are not using them. But it doesn't do any harm either. As long as our plugin doesn't touch the samples, they're going to just go through. They're going to be forwarded to the next plugin. The default pinning will do that for us. So, I don't know. I tend not to declare pins. And then there is this options no meter. That just removes the meters from the sides. I understand why you would want to do that for an effect like this that is just for monitoring or for reading what's happening. But for almost every other effect, I do want to see. In fact, that's one thing that I really like about Reaper, that it always shows me the input and output levels of JSFX. I think it should do that for any plugin, even for VSTs. And in Ableton, there is something similar, but unfortunately, it doesn't give you the scale. It doesn't show you the markings with the dB. So I think that the Reaper implementation is spot on. I really want to see what my plugins are doing in terms of audio, and I do want to see the levels. I don't want to just have colors. But that's just me. All right, so This first line is already an interesting one, because it's only setting the X retina if it's not set. I wonder why they're doing that. In my library, I just have a line that reads like this. And I don't really know what you're saving by doing this, bitch, by checking if the variable is not set. Because if you just set it again, then it will be just set again. Perhaps this has to do with this next part. No, I don't think it does. So yeah, I don't know why they're checking here. I think it was supposed to work just the same if we do this. So I will do exactly that and we'll see if something breaks. And it's also interesting to see that they are supporting Retina, but they decided to not support 60 Hertz or increasing the frame rate of the plugin. So that's something else that I want to try. When I look at this all the way zoomed out, it does jump a little bit in much the same way that I've been complaining about for the longest while now in this stream. It does jump around a bit, but it's mostly okay. It mostly just renders nicely. It goes across the screen good enough, I guess. But I wonder what happens if we increase the frame rate to 60 frames. Does it hold or not? Okay, so I guess I will zoom out and yep, I guess it is occurring the same thing on this plugin that occurred in our plugin. When you set it to 60 frames per second, when it's scrolling, it looks smoother and that's nice, but it jumps around a lot more. Gets a lot more jumpy. So between a higher frame rate and a stable frame rate, I think I prefer a stable frame rate. That was our conclusion, and I think that it was their conclusion as well. Or perhaps they just added this option to increase the frame rate on this version of Reaper and decided to not revisit the oscilloscope. Because the oscilloscope is definitely older than version 644. Anyway, here we are back to 30 frames per second, which is the default. When you don't declare, you get 30 frames per second. And then they're turning off the normalization. I wonder why they're doing that. Doesn't really make sense to me, because usually it's when you're computing with the samples, and in this case, you're not computing with the samples. You are just displaying them. I don't know. And then there is rack pause. We have to one thing to know is that the guys at Cockos, they really like short variable names, as you can tell by the built-in variables like X retina, not extension, and GFX, not graphics, and view retrig, not retrigger, or no denorm, not denormalization. And in some cases, they don't even have spaces around the equal sign. So they really like things short. I, on the other hand, cannot really understand everything that is going on with short variable names, so I tend to prefer longer variable names. So let's start to understand what rack pause is and rename it. So rack pause seems to be a circular buffer kind of thing, because on the sample section, it is being updated like this, and if it's bigger than that, it is resetting. Yeah, so this is an index or a read head and even a write head into a chunk of memory that isn't even declared, by the way. It's not even declared. And what I mean by the chunk of memory isn't even declared is that, oh no, yeah, the base address is here, so that's the declaration. You don't really need to declare this because every variable already exists and starts with a 0 in JSFX, but it's a nice practice to let your readers know that you're expecting to use this as a region in memory. And they are using this region in memory using pointer arithmetic, we try to avoid doing that, but they are using pointer arithmetic. And that just means that they have this base address for a circular buffer, effectively. And they traverse the circular buffer not by changing the indices, but by changing the base address itself. And it seems like the layout of the memory here, it seems like there will only be one buffer, and the layout of the memory seems to be so here is your memory. It starts in position 0 and goes on. And what they will have is a sample for the left channel and a sample for the right channel. So they will have sample for the left channel, sample for the right channel. And let's say that this is at time n minus 3. And then rinse and repeat. So that's for n minus 2, n minus 1, and n, and so on. In other words, they are interleaving left and right channels in memory, which is a smart arrangement, but it's not the arrangement that we tend to use in our implementation. We experimented with this way back, having a notion of multi-channel circular buffers, but we decided to not do that because it doesn't. I guess the reason was it didn't scale all that well, because if you have multi-channel circular buffers, you might as well have multi-channel almost everything. Almost everything we do will care about channels, from filters to waveform displays. Almost everything will care about channels, and then making everything multi-channel sounds like a hassle. So instead, what we tend to do is we have sample 0, n minus 3, then sample 0, n minus 2, I will not finish this. You get what I mean. We tend to pack things not by grouping channels first and then time second. We tend to group time first. So samples that are related in time are closer together, and samples that are on different channels tend to be further apart in memory, like this. And the advantage of this arrangement is that we can have a data structure and control over the data structure for this channel completely independently of this one. So when adding into the index to go to the next position in the circular buffer, we don't have to know what the size or the number of channels is. And that's advantageous, I think. And what's this hist size? Okay, I think we'll get to that in a moment. But yeah, rack pause. Well, pause is probably for position. Rack may be for recording. So that's our right index. Let's see all the places where rack pause is used. Yeah, seems like it is the right head into the circular buffer. So I will rename rack pause into circular buffer right head. But you can see that I'm doing this step by step because I don't want to rename these guys. They have rack pause in the name, but they are not the same variable, and we may want to give them different names. And when I say that this worked by pointer arithmetic, I mean that now our circular buffer write head, it starts as being 0. And instead of saying circular buffer write head into position 3, for instance, no, we say circular buffer write head plus equals 2. This line amounts to that. Plus equals 2. And this way we can always refer to 0 as the sample in channel 0, and always refer to position 1 as the sample in channel 1. And I do admit that this is convenient. Being able to do something like this is convenient. But in our layout, it doesn't get too bad either, because we would have something like circular buffers, and then you would get the channel, and then you would get maybe like, let's say, -3. And we don't write exactly this way, but that's the intent. The way that we actually write is something like this. And I think it's nice to have it this way, but this way is also okay for me. And I know that this is generally faster because we are doing more memory accesses to get this to actually work. But I mean, at least we are doing 2, right? One to get the channel and another one to get the index. And they are doing only 1. In reality, we do even more than 2, because we also need to know what is the length of the circular buffer to wrap this -3 around in case we need to. So I kind of like their arrangement in terms of efficiency. I don't like their arrangement in terms of doing pointer arithmetic is usually confusing. Right, so let's get to this next one. JSFX clear -1. That's interesting. First of all, I didn't know that JSFX clear -1 worked on the init block. I thought it would need to be on the JSFX block for this to work. And we did look at JSFX clear before. What it does is just, well, it clears the screen to a certain color. What we did not talk about, I don't think, was the fact that if you set -1 to JSFX clear, it has the effect of not clearing the screen between consecutive runs. Let's see if they have any other occurrence of JSFX clear. It appears that they do not. So they are probably going to play some kind of trick to scroll to the left by bleeding. No, they do not. Interesting. So I wonder what happens if I just comment this out. Oh. No, hang on. I brought the wrong effect. There you go. So it seems like everything just works. At least the basic functionality that we care about just works if we don't clear like that. Go figure. And then we have this G max length in ms. I think that this is just the maximum length in milliseconds. And I'm not in love with the variable name, but I don't need to rename it, I don't think. And it will be used in many places just to mean the maximum length that the view could have. Then there is this hist size. I must believe that this is the history size. Yeah. And I'm checking all the uses to see if there is any variable that has this name in the middle, like that one had. But it seems like no, that's not the case. So hist size is a variable that we can simply rename, and I think it could be called circular buffer length, because that's what it is. It's the length of the circular buffer. Then there is this gHold, which is just, it's probably, I don't know, but it's probably this hold situation. And I guess they are following the convention of prefixing everything that has to do with the graphical user interface with G. We do something similar. In our library, we prefix everything that has to do with the graphical user interface with JSFX like this. And then we have this need view update. What's that? Okay, I think I get it. So anytime that the mouse is doing something, so anytime that you are pressing a button on the mouse, it is going to set this variable. And somewhere it's going to check this variable like this. And it's going to check this variable, and then it's going to do some work, and it's going to set the variable back. So it's a way of saying, I only want to do some work under these conditions. But check this comment, only update if new FFT data is there or if the size changed. Why would they be doing FFTs for a waveform display? I don't think they are. I think this is a leftover comment from probably the spectrum analyzer. Oh, it is in many effects, so probably yes. And we can see that some people derived their code like this, and this is very explicitly derived from the oscilloscope. But even Psyche has derived stuff from the stock plugins. And yes, it seems to be a leftover from probably the JFX analyzer, which is the spectrum analyzer. Oh, and look who's here. Tail is here. Hello, great to have you. I'm doing the work of a historian, and I'm finding the evolution of stock plugins at this point, and I'm learning about how the scrolling waveform works here. And if you know more about the history of these effects, then let me know, because I'm interested. Yeah, so it seems like there are other effects, and let's just double check that the oscilloscope does not do any FFT. It does not. But the spectrum analyzer, which I was about to bring out, that one naturally does an FFT. So it seems like this same logic for needing to update when the mouse is pressed, that same logic seems to appear in many effects, from the spectrum analyzer to the gain reduction scope. And I don't even know what this one is. Zoom analyzer demo. What's that? Wow. I didn't know about this one. It is a stock plugin too. REAPER effect analysis zoom analyzer. It's by Cockos. Visualization scope analysis FFT. Okay. I can see how that's an FFT and how that's a spectrum analyzer, but it does some trippy effects. And they don't interact with the mouse, but cool stuff. Right, okay, so this is a leftover comment. Let's not dwell on that point so much. Let's get into the calculation of the circular buffer length. It is taking the sample rate, so that is going to be like 48,000. Multiplying by 2, because this is a stereo effect. Multiplying by the length that we are going to store at most in milliseconds. And we divide by 1,000 because we actually want, because this number is in seconds, or the sample rate is the number of samples per second, and this is in milliseconds. So to convert from milliseconds to seconds, we divide by 1,000. This number may be, I was going to say that this number could be a fraction because we are divided by 1,000, but unless the sample rate is really weird and small, this number will not be a fraction. But in any case, they take the effort of converting this into an integer using the awkward operator. Dale, since you're watching this, I want to ask you something. Why do people prefer to do this instead of doing that? Because to me, it seems like they do the same thing. They turn the number into an integer, but this reads a lot better, at least to me. So why would one want to do it the other way? I don't know. I don't get it. And why is this multiplying by 2.0? Every variable is a double, but here they decide to not put the 0.0, so it implies to me that they expect this to be a double and this to be an integer. I guess this is probably a leftover from C and C++ habits. But then why do they multiply by 2 again? The multiplication by 2 is probably to do left and right channel, but why do they do it twice? And I guess it makes sense because we saw that you can hold, even if you have a length of 5 seconds, you can, length of 5 seconds, you can hold and you can scroll to the past by 5 seconds. So probably that's why they multiply by 2 here. They want to have 2 lengths or 2 of these maximum lengths so that you can scroll. That's probably this multiplication by 2, and this is to the left and right channel. Tail is saying, the FFT effects only need to update the screen when the FFT buffer is full. But in the scope, it seems useless because there are always new samples, right? Yeah, but I think that there is probably some work that they're saving. Oh no, I was gonna say they're probably drawing to an off-screen canvas and bleeding, so they would like to know when you did something like zoom in to discard their temporary image. But that doesn't seem to be the case because there is no occurrence of bleach. So it seems to me that this need view update had to do with mouse interaction. So perhaps you are right, and this whole structure of this effect has been copy and pasted. And then that's why this thing exists here. And I do get your point. When you're doing FFTs, you need to collect enough samples to have a block to pass to the FFT computation. But in the scope, you always have new samples coming in, so you always have more work to do. Perhaps Perhaps what they're doing is they realize that you are zoomed out, so it knows that one pixel, one vertical pixel, corresponds to, like, let's say 1,000 samples. So it will wait 1,000 samples before it tries to do any work. And that is something that we kind of do in our implementation as well. So perhaps that's what's going on, but it doesn't use this need view update, not really. What it uses instead is this, or one of those. Yeah, perhaps one of these guys is going to be true and make this block run. I don't know. Okay. Okay, hang on. So there are two things for me to understand here. The first is, why do people prefer to do it like this? It is faster than doing it like that. Okay. I wonder by how much. Definitely not a problem here on the init block. But okay, I get it. I didn't know that. I didn't know that floor would be slower. I don't really understand why it is slower. I mean, why do compilers interpret this any differently? And hang on, when you're doing this, is it really like that? Ah, okay, I think I understand now. So when you do this casting in C, what you're doing is you are converting a float into an integer the smart way by looking at the number and truncating the floating point part. When I first read this, I thought that it was just taking the bits and interpreting the floating point as that sequence of bits, but as an integer instead. But I guess to do that, you would have to convert into a pointer to void and then back, if that's what you wanted to do. So yeah, I do get it how this amounts to that. And I get that this is slower. I don't understand why. I mean, the compiler could just do whatever it's doing for this into that. But okay, it is faster. Probably not a problem on the init block, but I get it. Oh wait, I know it's because of JSFX clear -1. So this need view update is because of the GFX clear -1. Yeah, I got rid of the GFX clear -1. And everything seems to still work just the same. And I understand the need for the GFX clear -1 and for the need view update with if you're doing something like an FFT, because sometimes you don't have enough samples to compute the next FFT, so you just show whatever was on the screen before. I bet that if we go into the spectrum analyzer, for instance, they have the GFX clear here as well, as one would expect. It's probably a copy and paste. And oh, this hist size is probably for histogram size. And here they had a hist size as well that I guess I renamed into circular buffer length. But yeah, hist size is not for history size, it's for histogram size. Oh boy. Okay, so they only have one occurrence of GFX clear though. Interesting. Okay, nothing stands out here. That is, maybe they don't update the whole screen unless some setting has changed. Oh, floor can handle positive and negative, infinity, etc. I didn't know that. All right. Good to know. Very low-level stuff here. Yeah, but I think that in the oscilloscope, that's not the case. I think that the oscilloscope always updates this screen because I just removed, very naively, just removed the GFX clear thing. So now a frame is no longer persisted to the next run of the GFX section, which means that if the GFX section was trying to save some work and not redraw, we would start to see the screen flickering, and it's certainly not flickering. All right, let's get to this. That's interesting. They are doing some timing thing. We did some timing thing and decided to not use it after all. We decided, so there are two ways of keeping track of time. One way is to look at the clock. This is what time precise gives you. The second way is to look at how many times the sample block has executed, the sample section here. Because the sample section is going to be, for instance, updating this variable. So we can look at this variable to have a notion of the passing of time. And we can rely on this block running 48,000 times a second, or s-rate times a second. And if samples are being dropped, then that's a bigger issue. We don't even have to care about that. So we tried both approaches and ended up using the sample counting approach because we tried to avoid time precise because we thought that time precise was going to be too slow. But they are using time precise here. Oh, and the computation that they use here is something that is familiar. We saw something like this. We actually implemented something like this. It is taking the difference between time precise and the last time precise. So the last time we drew something. And it's taking that difference and taking the maximum and blah, blah, blah to get the offset. So it is offsetting everything to the left. So it's taking, when you're not holding, it's offsetting everything to the left to make the thing scroll. And the offset is based on time precise, it seems. That's interesting. I was wrong about the needville update. However, bypass the scope and I think you will see why needville update is there. Okay, so one thing is when an effect is bypassed, the GFX block is still running. And then samples are coming in, the effect is running, samples are going through the effect, and when I bypass, samples are no longer running through the effect, but the GFX block is still running. I can still zoom in and go into the past and whatnot. So I don't think I get it. I'm sorry, but you'll have to explain more. Need view update is working just the same. Even with effect bypass. Or at least it seems to me. I don't know. Yeah, so it seems like they're computing the offset of the scrolling not by counting samples, but by looking at the time. Good to know. Perhaps looking at the time is what we should be doing after all. We did it, it worked, but sample counting seemed simpler. I don't know. All right, so this sample section is super straightforward. If you're not holding, so if this is not engaged, then just store samples 0 and 1 and update the circular buffer by adding 2 to it. And if it's bigger than the length, wrap around. Otherwise, just add 2 to it. Why write it this way? I don't know. It's okay, but it's not the best. I would have written it like this. I'm going to be using a clever trick that we actually don't use in the library, but I saw it in the REAPER forum. It's kind of cute. So I will rewrite this logic in a cute way. So add 2 and subtract the buffer length. But only if yeah, something like this. Perhaps that's not how I would write it, but it's a clever little trick, and I think it's fun to talk about it. So the trick is, this is a Boolean operation. It's a comparison between these two numbers. The result of a Boolean, or the representation of a Boolean, the result of this comparison operation is going to be either 0 or 1. 0 being false, 1 being true. That's just how true and false are represented in JSFX, and in C as well, incidentally. But it turns out that we can use this number for arithmetic. So we are misusing the Boolean as an arithmetic number, as a number, regular number, and we multiply by this length. So if this is false, this is going to be 0, right? If this is false, the whole thing is going to be 0, and you just get an update to the circular buffer right hand. But if this is 1, it means that we need to wrap around, and this is going to be 1. This whole thing is going to be just circular buffer length, and then you wrap this whole thing around. And this is how you do a circular buffer update without branching, without using a conditional or an if. And that's advantageous because using ifs is a bit slower. Branching is a bit slower. It gets down to very low level things in terms of like trying to predict which branch you're going to go to, and speculative execution, which can lead to security issues even. It's crazy complicated, but it's kind of fun that you can do this circular buffer update without branching by misusing a Boolean as if it was an integer, because under the hood it actually is. But never mind that. Let's get back to their code, because their code works just fine. Just thought I would bring up this branchless circular buffer update because it's such a cute trick. It's such a cute trick that I am surprised that they are not using it here. But it's not updating every frame anymore. So if the effect is bypassed, then it only redraws if you change any settings. But if the effect is not bypassed, then it redraws every call. Well, how can you tell? How can you tell that it's not? It is redrawing. In my version of the effect, it is redrawing because I got rid of GFX reset. I think it is. Got rid of that guy, so it is redrawing on every frame. It doesn't have to because nothing is changing, but it is redrawing every frame. So yeah, I don't really get it. Okay, let's move on. So this is a very simple circular buffer update. And it is worth noting that I was right. It is storing every sample for the whole 10 seconds. And it is not trying to... So that's one of the questions I wanted to answer on these dramatic readings. I wanted to know if they were doing... I guess in this case, it's interesting to even ask, are they doing any kind of... I want to say downsampling. Are they doing any kind of work to go from 40,000 samples a second to perhaps like 100 that's necessary to draw this 1 second? Because there is 100 pixels across the screen, so there is only 100 samples that you would need. And are they doing this downsampling from 40,000 to 100 on the audio thread? They're not. The audio thread is not doing much work at all. Everything is happening on the GFX or the UI, the user interface thread. So there you have it. They are storing every sample, and most of the work is done on the user interface thread. All right, so they have this small mode situation here. This is probably to hide some of the buttons. When it is here, it's showing all these buttons, and when you make it smaller, it starts hiding some of them. And that's probably a naive way of detecting whether you are on, whether you are embedded on the mixer control panel like this. And that used to be necessary, but these days there is a variable that tells you if you are embedded. But probably, again, they haven't updated this effect since that variable came into existence. So they are just doing the naive thing of checking the dimensions of the screen to tell if you are in this small mode. And perhaps you will want to have the thing not even in the MCP, but you will want to just have it small for whatever reason. Who knows? Small window. And Jim is here. Hey, Jim. It's good to see you too. For what it's worth, if you add AAA plus equals 1 below, then this will stop counting when bypassed. This will stop counting when bypassed. You say counting. Okay, let's go to this location. Okay. Okay, I see what you mean. So you are doing this as a way of checking whether this block of code is even running. And it will stop counting, so it means it will stop drawing. Or at least it will stop running this block. So that's actually an interesting observation. It may reveal something that I didn't know about JSFX. Let's write a quick plugin to test this out. I'll call this persistence of user interface when bypassed. And it will go like this. It will have a GFX block. And I think I will do something like this. I will GFX set 1, set to white, then GFX rect from 0, 0 to, or from 0 something and it will have a size of 2020. This something will be the sign of x, where x plus equals, so I guess in the init block, x equals 0, and then plus equals perhaps 1, perhaps a small value like this will do. And I guess I will put this at 100. And this is going to be a number between 0 and 2 pi. So let's just multiply this by 100. So it's going to go up and down. Yeah, I think just by staring at this for a moment, I think that that will do what I want it to do. Okay, we have a small square going up and down, and naturally it is going to go all the way up. So I'll add 300 because the sign may be a negative number. So now it is always on the screen. No, now it's going to be low. Let's add perhaps 150. This way it's always on the screen, and this is too slow, so I'll make it faster. Okay, we have a bouncing square. Now, what I'm interested in learning is what happens when I bypass the FX. The JFX block is still running all the same. So the square continues to bounce. But if I have a sample block, then this sample block will stop running. So again, I'm going to use the trick of creating a variable and adding 1 to see if it is a certain block of code is running or not. So you can see this number increasing, but when I bypass, it stops increasing. And when I turn it on again, it continues to increase. So this block only runs when the effect is receiving samples, which of course makes sense. It also makes sample. So there is that. Now I'm going to do something different. I'll say needs update equals to 1. Needs update equals to 0 at the end. And so far, so good. Now, we are going to only do this whole work if it needs an update. Okay, so when the effect is not bypassed, we see the bouncing square just the same. But when I bypass the effect, the bouncing square stops because this needs update is set to 0 here. It's never set to 1 on the sample section. So this block stops running. And what I found interesting is we continue to see the square. My understanding was that in the JFX block, unless you do JFX reset, is it not reset? What is the name of the variable again? Hang on. I forget the name of the variable. Clear, JFX clear. So I thought that if you don't do JFX clear -1, so if you don't have this line, then you are required to draw something or you would get a black screen. But that doesn't seem to be the case. That's interesting. I didn't know that. Yeah, so it seems like if you are not drawing something, if you're not drawing anything at all, then the screen persists. And now, just for good measure, I will do something like this. I will set to red, and I will draw a rectangle in red. Okay, so that's what I was expecting. If I do any kind of drawing, then I lose the white square. But if I have this clear equals to -1, then I will not lose the square. Just like this. Interesting. Okay, so here's what I learned. If you don't draw anything in the JFX block, it is going to persist the previous drawing. That's what we are relying on to make this version, our version of the oscilloscope, work. We got rid of the JFX clear, but because we are not drawing anything when the effect is bypassed, we are literally not touching any of the JFX functions, so it just persists the previous frame buffer and continues the same image. If we wanted to make it go black, we would have to be explicit about it. So what this means is if you touch any of the JFX drawing functions, then this persistence will not occur. And if you touch any of the drawing functions, it will start by the first time you do any kind of drawing, JSFX is going to say, okay, I need to clear the frame buffer, and now I will draw what you asked me to. Unless, of course, you have JFX clear -1, because in that case, see, that's why I thought that this was only available in the JFX block. It says so right here. But it's false. It also works here on the init block. If you have JFX clear -1, then it is always going to preserve whatever was there. So as the block goes up and down, it preserves the previous positions of the block. And when I bypass, it continues to preserve the whole drawing. Now that I say this out loud, I think that we ran into this as a bug. There was some situation where I wanted to just erase when you started bypassing a plugin or something, and we were not touching any of the JFX functions, so it was just persisting the previous frame buffer. You live, you learn. If you don't touch any of the JFX functions, the previous frame buffer is persisted. If you touch something and you want the persistence to still occur, you have to be explicit and ask for it. And in their plugin, they could, as we just proved, in their plugin, they could rely on the implicit persistence of the frame buffer by just not drawing anything. They could have. They decided not to. They decided to be explicit about it. Perhaps it's a leftover from some other plugin. Perhaps it's just a way of being explicit and saying, I want this to be the case, so please, dear reader, know that I want this to be the case. Whatever the reason is, that's what they did. All right, awesome. I learned cool stuff. Okay, so if you are in Retina, this if your monitor is a Retina display, in my case it is, then this variable is going to be 2, and then you're going to set the font to Arial. Otherwise, you are not going to. Awesome, interesting. So if you are in a Retina display, it's going to render with Arial. That's the font that we see there. Otherwise, it's going to render with font 0. Font 0 is the bitmap font. And this is what it looks like. It's very small because I do have a Retina display. But see, it's there, monospaced font, bitmap font. So that was their solution for this tricky issue of rendering fonts and whatnot. They decided to go with bitmap on non-retina displays and decided to go with REL, as almost everyone does on retina displays. But we are doing better now. We are detecting the operating system and we are picking better fonts than REL. Good for us. Request mouse cap to be set even when mouse button not down. This is something that we talked about with Justin Johnson when we had him over on the stream. He said that you do need to call this so that you can use mouse cap. And this is supposed to get your character from the keyboard, but it's not even doing that. You're not caring about keyboard input in this effect. You just have this because it has a side effect of making this available. Otherwise, I think Justin said that he would have to like click first to capture the mouse and then you would be able to read mouse events or something like that. But in fact, this is something that you almost always will want if you're doing any sort of mouse interaction on Oh, I didn't know that you could scroll on this. Cool. What does it do? Oh, it changes the length. I didn't know that that works. Very cool. Right, anyway, so I don't see a reason why you would want to not have this. Because you most probably will want to be able to see the mouse situation if a button is pressed or not. So when I was talking to Justin Johnson, I said, yeah, I probably want to have this as part of my library. And I guess I didn't actually implement that. Let's see if I have a get char situation. Oh, it is here as a comment. Yep, let's get to that right now. Yeah, I don't think there is any reason why you would not want this to be the case. So we are just making it part of the library and we are putting it in a location where this is going to be called in the beginning of the user interface thread if you're using the library correctly. So we are just forcing you into that stage. Then colors, I guess we have a better solution for this. We have a whole design system for this, but they're setting colors here. Then they have a draw button situation. Most of this is to do the user interface that we don't really care about on this reading, because we're mostly interested in the drawing of the waveform, not on these buttons here. So I'm just going to skip over that part, but it is important to note the style that they're using here. So let's take a moment to just glance at what they're doing. It seems like they have a function to do the drawing of the button and another function to detect whether you are clicking on that button or not. And that's this function here. Cool. And the drawing is nothing terribly interesting. This is how you do a rectangle that is not filled in. And of course, they are using the style of the pseudo objects. That's what this instance is about. The JSFX pseudo objects. We are not doing that. We are using real objects. Yeah, okay, whatever. All right, so they also have a drag slider And globals, is that a thing? Well, it must be, but I didn't know about it. I always thought it was just global. In fact, that's what the syntax highlighter seems to think as well. I wonder how many people are using globals. I am using globals? Oh, there you go. Oh, but hang on, that's my copy of the oscilloscope. That's not code that I wrote. Okay, so Cockos is using globals. Cockos again. Well, oh, but this is not globals. This is derived from a Cockos plugin. This is derived from a Cockos plugin as well. This is not. Or maybe it is. Maybe it has been copy and pasted from somewhere. I don't know. So it seems like Psyche is using globals with an S. And this is just a comment. Oh, there you go. You live, you learn. Then, okay, so function to capture drags on a slider. Like this, I can click and drag. And then drag slider precise. Oh, that is if you have command hold down, probably. I don't know. Let's see. Yeah, if you hold down command, then it decreases the effect of the differential of your mouse. So if you drag for 1 centimeter, that is going to affect less because you're holding down command, and probably 4 is command. Then cycle slider is probably for this one. Okay, whatever. I will not get into that. And we get to the meat. This is us dealing with the mouse interactions. So I think we can skip over this block. But it's interesting to note that they are being explicit about the slider that they are changing. So view max dB. That's slider number 2. And they're being explicit about this. I never really understood, and I don't understand to this point, why you would call slider automate. Because it seems like if you don't, so let's first take a look at what happens now. So we are talking about the second slider, okay? That's V-zoom. So you can change this, you can change this around by clicking and dragging on the interface. Great. And as I do, you can see that the slider is changing as well. But watch what happens if I comment out slider automate. Continues to work just the same. The slider is moving as I move this. I don't really know what the point of slider automate is. Judging from the documentation, it was supposed to do that. It was supposed to let the interface know that I'm changing a slider. Perhaps this is important if you're doing automation, because perhaps the precision of the updates is not good enough unless you call slider automate. So it's like a hint to Reaper to say, I'm changing this value, okay? But come on, Reaper already has this information. You are setting a variable. That variable is associated with a slider. So why do we have this function? I never really understood it. Still don't understand. Then, okay, we do a bunch of things to detect if the buttons have been pressed, and if they have, then we do stuff like we change the retrigger variable, perhaps. Nothing majorly interesting. Okay, Up to this point, it was just updating sliders based on the mouse. Oh, this is changing the numbers from milliseconds to seconds. Check that out. For instance, here. Cool. This is checking if the number is smaller than a certain threshold, and if so, converts to seconds or stays in milliseconds. Same with hertz. We saw that happening here. Then there's the mouse wheel situation. That's just going to update some variables, some slider perhaps. Yeah, this slider over here. And again, the trick to convert into an integer. And this is probably a read offset. Yeah, most probably, because it is doing a read offset times 2, probably times 2 because it's left and right channels. What the heck? Why multiply by 1? Oh, okay, I get it. So we have our write head, and then we are reading an offset. So we are reading back into the past based on the write head. So we want, for instance, 2 samples ago, let's say. Let's see other places where this is used. This is only used here, so I will rename this into read offset. Perhaps I will even call it circular buffer read offset. And then this line starts to make more sense. This is the write head. We are subtracting the read offset times 2 because the circular buffer stores left and right channel, so it goes in steps of 2. And then we have our read pos u. So this is the write head. I guess this is the read head. Yeah, I can rename this as the circular buffer read head. And this is just wrapping around. If you got way to the left of the circular buffer. When zoomed out, adjust interval so that each peak represents a discrete number of samples. This is the crux of the computation. And the interesting thing is that I was gonna say that the bulk of the work is done here, but it is not under this guard. But it seems like it's not the bulk of the work because I don't see any loops. So what is view ADVN? It's probably view advance. Yeah, okay, so this is the view size in samples. That's how many samples we are going to display across. And this is the width of the screen. So the width of the screen divided by the number of samples that we are going to show is the increment. So each sample represents like 0.001 pixels. That's this variable, 0.001 pixels. Where is it used? Many places. I guess I will start by renaming this, because this is rounding. So this is a neat trick. In JSFX, there is floor and there is ceil to take the floor and the ceiling of a number, but there is no round. And the way that you can round a number is by adding half and taking the floor. I'll let you think about why this works. It's not that hard. Just think about numbers that are lower than 0.5 and numbers that are higher than 0.5. And you can convince yourself that that's going to work. So this is just taking the rounded version of that number. So let's rename this variable first. Let's just check that it's not part of another variable name. It's not. So let's rename this one. So this is what I would like to call the sample width integer or rounded. And this is the sample width. In other words, what is the width in pixels of a sample on this display? So when zoomed out, adjust intervals so that each peak represents a discrete number of samples. So it means that they are, when you're zoomed out, like we are in this view here, each peak, so what I'm calling a slice in my library, but each pixel here represents a discrete number of samples. So that is what we are doing as well. Each pixel represents like 7 samples, 8 samples, that sort of thing. That's what this is. It's rounding that other number. Then it's checking if the width of one sample is greater than 8. It's going to do some extra work. Otherwise, it's going to say that the rounded number is actually 0. Interesting. I wonder how they're going to check. Okay, they're going to check for that 0 later and do something special in that case. But I wonder what they're doing here as that special case. So I guess this width will be greater than 8 if you are zoomed in, so that one sample, so that, oh, come on. So that, okay, so that one sample takes more than 8 pixels across the screen, which should be the case around here, I guess. So I guess what's the special thing about this is that it's going to start drawing these colors, probably green for left and red for, green for left and purple for right, or something like that. Yeah. So it's a special case when you're zooming in. Okay. Okay, so it's rounding that number. Yeah, this is just rounding that number. And getting more samples. Okay, so there is a discrete number of samples on the screen, and that's interesting. Okay, pay attention to the left and the right of this situation here. You never cut a sample in half. See? On the right, I guess it's kind of obvious because it's locked in this position, but look at the one on the left. It never cuts a sample in half. That's what this part of the code is doing. Only update if the new FFT is blah, blah, blah. We already looked at this comment. This comment is wrong. Interesting. Need view update 0, blah, 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 rect 2. Scope height. Okay, whatever. What is this? It's scope something. Taking the log and dividing by 20. seems like something you would do to convert. Well, log would be something to convert from linear to dB, and dividing by 20 would be something to go back from dB to linear, but this doesn't really make sense. I don't know what they're doing on this line. I don't know. This exponential with a negative number and whatnot, it really does seem like a time constant, but why would you have a time constant here? I don't know. Drawing the horizontal grid. And here is that thing again. I really don't understand that. But this is just drawing the grid, so I don't have to worry about it. Draw the vertical grid. Okay, we can skip that. Let's just skim to see if the comment is true. It seems to be. It's going over and drawing lines. And even drawing labels. Then we have our GPTR, of course. That's the read pointer. So this was the read head. And I guess it is the read head has the purpose of resolving the offset as you scroll left and right. And this is going to be the read head for the actual drawing. So it will need to, so one read, the read head here gives you this position of this sample here. And then we go minus view size -2 and wrap the pointer around. So it will get us this here. And then we are about to loop, I hope, I bet that we are about to loop and do the drawing. If you are on hold, then whatever. If view retrig is greater than 1 and you're about to loop, and you loop, all right. And then you do a bunch of things, but you're looping. That's good news. We found the drawing part. Oh, so it is a way to convert from dB to linear, but it is a convoluted way of doing that. Yeah, okay, now I get it. Log is base E and exp is base E, so probably base E is faster than base 10. So exp is faster than 10 to the power of. And then this is just saying I will compute the same thing. It's just dividing by the log of E on both the numerator and denominator kind of thing. I don't know. In any case, the point is it's converting from dB to linear, but in base E instead of base 10. Probably to make things faster. I don't know. I wonder if this is a significant enough performance boost that we should include in our own dB to linear, because we do it this way. Guess I will leave myself a to-do to investigate this. Right, okay, so let's see. This is read pointer 2, because of course it is. So let's keep track of things. This is the read head. That's this position here. This is read pointer. That's this position here. Then we have read pointer 2, and that's going to probably be the guy that goes from left to right and reads each one. And then you have left and right. Then you have a bunch of conditions. And you manipulate some pointers and whatnot. But you don't actually do any drawing. Oh, okay, so hang on. What the heck? You're not doing any drawing. What are you? What is exactly that you're doing in this loop? Oh, you're taking the maximum and the minimum, aren't you? All these comparisons and this weird situation going on here. That's so you can set LL and LR. And I wonder what L, left and right, okay? So this second letter is for left and right. But LL and LR, what is this first L? Is it for like the lowest, the least? When do we actually capture that? We capture when L is greater than 0 and LL is less than 0. Oh, I will not try to make sense of this. It doesn't really make a lot of sense, but it seems like you are just looping over here. And you're just getting one variable out of this loop. So it's not the case that you're going from left to right and drawing each of these samples. Because you're just setting one variable. That's the result. The result of this whole loop is so that you will end up with the right values in LR and LL, it seems to me. Let's see where LR is used. Oh, fuck, that's not even the case, because LR is no longer used. So perhaps the point of this whole loop was to set this read pointer to something. But it seems to be just iterating over stuff. Perhaps the point is to set this to something. No, but that one is just going over as well. Oh, okay, but this is under a conditional. So this, yeah, so I guess the whole point of this whole thing is to set this variable, not this ones, because this is going to be used later. Okay, I got it. The whole point of this whole loop, yeah, this variable is not going to be used anymore. These variables are not going to be used anymore. The point of this whole loop was to set this variable to something. Weird. If the sample width is less than 1, that's a huge thing. So if the sample width is less than 1, it means that we don't that each sample doesn't occupy even 1 pixel on the screen. So that's this situation here. And we do something special when a sample is visible, when you can see each sample. So I guess this is the drawing of the green and purple stuff. Or I guess the other way around. So this is the block where we don't draw the green and purple. Yeah. So each sample here doesn't even take 1 pixel. So we will need to accumulate multiple samples into 1 pixel. And that's a loop. Hey, we have something similar in our implementation, just taking the maximum and the minimum. Hey, we have something similar in our implementation. And it's truncating. We also have something similar. All right. So by necessity, because it's an oscilloscope, it's doing this work here on the JSFX block. We did this work on the sample block, but it amounts to the same. And then we have a minimum left and a maximum left and right. Yeah, we do something very similar to this. It's doing the sample truncation as well as the positioning at once. So we have a minimum and then we have a bottom, and we have a maximum and we have a top. So the maximum is the sample and the top is the position on the screen, but they are doing this in one pass. But okay, something similar to that. Then last pixel. I don't know why they had to repeat this, but whatever. And then draw lines. These are probably these lines. These ones. And when you have multiple pixels per sample, which is this case. Oh, so we were not in the case of multiple pixels per sample, so we were in this case. So it was probably just drawing this purple line, the contour, effectively. And then this is just taking care of drawing buttons. We made it. We read the whole thing. All right, so interesting facts about this. We were asking questions about other effects. How do they communicate between the audio and UI threads? By a simple circular buffer. Which thread does most of the work? The user interface thread. How do they scroll the pane across the screen? By repainting. We are doing something to draw off screen, and this prevents us from having to loop every time. They are not trying to do that. They are just looping over all the samples they collected. It seems to me. It seems like they are just iterating over all the 40,000 samples that they collected to draw this 1 second. And it seems to me that they are drawing this line, this purple line, by what do they do? Do they use rect? When they are on this situation, multiple samples per pixel, they are using a line. Yeah, mystery solved. Okay, so how do they scroll the pane across the screen? They repaint and they recompute this stuff. So does it flicker in any weird way? Kind of does as it moves across. It does flicker in weird ways because the samples are rounding in different ways. Yeah, you can sort of see it flickering across as it moves across, because we have this notion of like each pixel is 100 samples, but as it scrolls, this 100 samples is a sliding window that talks about different samples. These different 100 samples on the circular buffer. So you will end up with this flickering here. The way you fix this flicker is by committing to which 100 samples you painted. And that's something that we do because we paint off screen. But it seems like perhaps they are doing it this way because it is an oscilloscope and you would be able to zoom in, or perhaps they are doing it because it is okay to do it this way. But I think that we can optimize by at least caching our decisions here. And that has two advantages. The first is we don't keep looping over every time. And the second advantage is it fixes this flickering across the screen. Fun stuff. Last write. Yeah, it can be. Can be the last write, the previous write. I don't know. And isn't it to detect zero crossings? Perhaps that's what they were doing. I don't know. That loop was super weird to me. This one specifically. But to be honest, I'm more interested in this part, which answers most of the questions for me. Seems like repainting the whole screen is okay. Perhaps it's even better than bleeding. And it seems like there isn't any other magic going on. So in essence, I think I'm going to stop with this series of dramatic readings. I think that this one today will be the last one. And I guess what we learned is that we can communicate between the threads by just storing all the samples. But I think that our idea is better of doing the downsampling on the audio thread. So I guess it makes sense to do this work on the audio thread. Unless we wanted to be able to support any kind of zooming. And how to scroll the pane across the screen, I guess it's time for me to perhaps simplify stuff and not do the off-screen drawing. Or maybe just have an array in memory. Perhaps repainting everything will be faster than doing a bleed. I don't know. Or perhaps a bleed is good enough. But the bleed has the disadvantage of being slightly more complicated because we have to bleed two images and we have to be smart about their positioning. And most of this has been implemented already, so we might as well just have it. But it's good to know how they are doing stuff. And with that, it's time for me to wrap up. So thank you, Tail and Jim, for showing up here on the chat. Thank you everyone else who is not showing up on the chat but is watching this now or in the future. I will take tomorrow off, but I will be back on Friday to do something. Perhaps to revisit some of our decisions on the waveform display, perhaps to just continue pushing forward using the waveform display to do effects. The first of which will be this, which is something that you are supposed to put on the TCP or the MCP to show the waveforms in pretty much the same way that this does, but I think that this one will be better. I hope. We are doing some smarter things on this one. And yeah, I will be back to do something. We'll see what exactly. One of the things that definitely needs to be done is when you have two channels, they scroll out of sync and they glitch, they flicker. You can see this one flickering. So we need to see why that's happening. We need to figure this out. And the reason why they kind of move out of sync has to do with the whole alignment thing that we talked about in the beginning of this stream. We talked about how we talked about the memory disposition of the way that we use memory. And the disadvantage, I guess, one disadvantage of the way that we are doing it is that they can go out of sync like this. They kind of scroll out of sync. So we can look into that. Perhaps we will have to come up with a multi-channel circular buffer to fix this. I don't know. We'll know more about this on Friday when I'm back. Yeah. Thanks, everyone. I see you on Friday. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.